properties of circles. This is a common lesson in any geometry class, but specifically for ULOLC Online Learning Center, Geometry B, this is Unit 7, Lesson 1, Properties of Circles. I think everybody knows what a circle is. You've seen one. So let's just identify some parts of the circle that you probably already know, but just to review to make sure we got it. Okay, so the radius of a circle is the distance. I'm going to just label that R. Okay, it's the distance from the center of the circle out to the edge. Okay, my circle here is in red. This is my circle that I'm referring to. The blue is, I'll get to here in just a second. Blue is like an arrow. Alright, so the radius is the distance from the center of the circle out to the edge, and it doesn't matter where you draw that radius. Okay, so that's the radius. The diameter is all the way across. So this guy all the way across here, as long as it goes through the center, that's the diameter. Okay, and notice that the diameter has two radiuses, right? Here's a radius and here's a radius. So the diameter is also two radiuses. Okay, the circumference is basically the perimeter of the circle. So if you're going to build a circular pen for your goats or horses or whatever, you would need to know the perimeter of that so you know how much material to buy. Okay, I'm sorry, ranching community is the first thing I think of is a pin. So the circumference is basically the same thing as a perimeter. I ran out of room, but it's basically the same thing as the perimeter. So it's the measurement all the way around. Okay, and there's a formula for circumference. I'm going to call circumference a big C down here, and the circumference is always pi times the diameter. Or, say you're given the radius, you could just do pi times 2 times the radius, okay, because right here I told you that the diameter is 2 radiuses. Pi is a number that mathematicians have measured, eons ago. We could go into the history, but it's basically any circle. If you have if you draw it, exact with a compass or whatever, and you measure the circumference and you measure the diameter, pi is basically a ratio between the circumference and the diameter. I mean, you can kind of gather that from this equation, but so it doesn't matter the circle. It could be a huge circle, it'd be a little bitty circle, so they measured several circles, and this ratio was always the same. Okay, and so pi, the famous number pi, is 3.1415, yada 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 yada. Right? We usually just worry about 3.14 when we're estimating, or we use the calculator, the pi button on the calculator, and it gives us a few more digits, gets things a little bit more accurate. But anytime you use pi, you're going to be estimating anyway, because pi is a number that goes on forever. Okay. The other thing related to circles is the area, and the area would be how much pie am I going to eat today? I'm going to eat the whole pie. Well, how much of that pie is there? Well, area is pi r squared. Okay, now obviously this pie is round, but to help us remember a silly joke, pi r squared. Alright, pi r squared. So, and I used capital R here, so I'll use capital R here. So pi times the radius squared is the area. Okay? Alright, some other things about circles in this unit has to do with concentric circles. Alright, concentric circles. Okay, what that means is that I have a circle with a center. Okay, and then I have another circle with the same center, even though I can't draw straight. I'm telling you. So when they have the same centers, they're concentric. All right? Sometimes concentric circles are like, you know, it's like a bullseye. Think of a bullseye. If anyone's ever played darts, a bullseye is a bunch of concentric circles. Okay, they all have the same center. All right. If you have two circles, but they have different centers, or their centers are not in the same exact location. Okay, these are not concentric. Okay, they're just circles. Now then, if the radius of both circles, we'll just call this radius 1, radius 2, if they are the same, then those circles are congruent. But they're not concentric. The only way to have congruent concentric circles would be to have a circle the same exact size on top of it. So basically, is this going to work? Alright, if you got a circle on top of a circle at the same center, then that would be congruent. Notice how my pen even tells you they're both the same. Concentric or concentric congruent. Okay, so the only way you can have both congruent and concentric is they're on top of each other. Congruent, they have the radiuses equal each other, and then concentric, they share the same center. Okay, concentric, congruent, and congruent concentric. All right. Tangent circles. Tangent circles. Okay? Tangent means basically you're touching. All right? Just think of the word tangent as just touching. Or touching at one point. Okay, when we get into trigonometry, tangent will mean something else. But when we're talking about circles or when we talk about tangent lines or stuff like that, we're thinking about something that just touches something else at one spot. Okay? So, there's two ways of looking at this. I can have a circle and another circle that just touches. Okay? So they touch right here at that one spot. So these are tangent. And these circles are tangent to each other. And since they're one's not inside the other, they're externally tangent. Okay? Now then I can have a circle and another circle inside. Okay? And they can touch at one spot. Again. Alright? So these are internally tangent. Okay? Externally they're both outside. Internally one's inside the other. Okay? Alright. So tangent circles. Alright, another note on tangent, just because I'm thinking about it. I can have a tangent line. And this comes later, but I just want to touch on it. Alright, I probably should have drawn it in two different colors. But if I have a line just touching the circle at one point, this line is tangent to the circle, I can make this whatever shape. I can make it a triangle, and the triangle is tangent to the circle. Okay? So tangent is just touching at one place. Alright. equation of a circle. Standard equation. Standard equation. Hope I didn't get off centered here. Of a circle is always this: x minus h squared plus y minus k squared equals r squared. Okay, so x and y is basically an ordered pair. Is any point on the circle. Okay? We don't really care too much about that right now. What we really care about is the h and the k. Alright? The h, k, if I write it as an ordered pair, that is the center. Okay, now notice that the standard form has minus signs. Okay? So if my center, and I'll show you here in a second, if my center is in a positive, everybody's positive, then these are going to be minus signs. If these become plus signs, then we've got negative. Then we've got these points are negative. Okay? So that's the standard equation of the circle. The other thing to note is the radius. Right here, r squared, plain old r is the radius. Okay? So, radius of the circle. So, there's two ways of looking at this. The first thing is to come up with the equation given a graph of a circle. Okay? So I'm going to flip this over. Okay? So this is my graph. You know, my y-axis, my x-axis, and I'm just going to randomly put a circle out here, okay? And I'm going to tell you that that's the center, right? and let's see if I can do a little bit better job of drawing. Or cheat this a little bit, okay? I'm going to cheat a little, well, not really cheating, just going to take a little bit more time to draw the circle. Okay? Alright. So, if I tell you, or you can measure, and this is a beautiful computer generated image, and I tell you that this radius, or you can measure this radius, is 4. Okay, I can tell you, or you could read off of my graph here, that the center of the circle is at, let's see, where did I draw it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so there's a center of my circle. So if I give you this and I say, give me the standard equation for this circle that I represented here. Well, remember my formula, x minus h squared plus y minus k squared equals r squared. So if I want the equation of the circle, all I got to do is replace the h, the k, and the r with the given values that I have here. Okay? So the h, since it goes with the x, the h is the x coordinate of the center. The k, since it goes with the y, is the y coordinate of the center. And then the radius is the r right here. Okay? So, if I just want the equation, it's going to be x minus 5 squared plus y minus 6 squared equals 4 squared. And actually I want to simplify that. Go ahead and do that math there. So x minus 5 squared plus y minus 6 equals 16. Oops, squared. Okay. Hopefully you follow that. Now let me give you one. Let me give you one where the signs are a little bit different. Okay, so I'm going to draw a circle over here. Okay. Nice, really super round circle there. Okay, from my graph, if all the squares are 1, I can read off the graph that this is 3. Okay, or I'll tell you that it's 3. And then the center of the circle, this point right here, is 1, 2, 3. So negative 3. And 1, 2, 3, 4, 5, 6, 7. Okay, so that's the center. So what is the standard equation for this circle? Okay, let's write down the equation. Y minus h squared plus, sorry, I think I said y, I meant x minus h squared plus y minus k squared equals r squared. Okay, so the h goes with the x, it's the x coordinate. The k goes with the y, is the y coordinate. So if I wrote exactly how it is written here, it'd be x minus a negative 3 squared plus y minus 7 squared equals 3 squared, or 9. Okay? Now see this right here. I've got a minus a negative. Anytime you have a minus a negative, that's the same thing as saying plus. If you did that in your calculator, if you did 4 minus a negative 3, you would get 7. Okay? So to simplify this, or to clean it up, this is really x plus 3 squared plus y minus 7 squared equals 9. And remember, 9, r squared equals 3 squared equals 9. That's where the 9 comes from. So that's the standard equation. Notice the plus. So if we work it backwards, and you see a plus, that's a clue that when you see a plus in the equation, that's a clue that it's a negative. When you see a minus sign in the equation, that's a clue that it's a positive. Okay? Okay, so let's work it backwards. Let's say that I'm going to give you an equation of a circle, and I want you to tell me what the center is and the radius. Okay? So this is the standard form. I'm going to leave this here just as a reminder. Okay? And then let's say that I give you this equation, x plus 4 squared plus y plus 6 squared equals 25. Okay? So if I want the center, remember the center is the h and the k, all right? So that means hk is right here. But because this is a plus and the standard form is a minus, that tells me, that's my clue, that 4 is negative. This is a plus here, standard form is negative, that's a clue that this 6 is a negative. Okay? So my center is at negative 4, negative 6. Okay? Because if they were minus signs, then that means the h and the k's are positive, because the minus signs are the standard part of the equation. And like I showed you, if something's negative, we have a minus a negative, which is the same thing as a plus. Okay? The radius, all right, remember the radius is squared. So and in those other ones, we squared that radius. So to find the actual radius, we'd have to take this number here and take the square root of it. So the radius is going to be the square root of this number right here. So I did a nice one, so it's nice and nice and even, or nice and not decimally. Okay? So the radius is 5. So here's the standard form of an equation. I found my center and my radius. Okay? The only other thing that I can think of, and I want you to look at, is if you are given an equation that looks like this, we'll look at it both ways. Okay? So So if this is your standard form of the equation, what if you're given this as your equation? Let's just pick a number. Okay? Oh no. There's no minus or plus. Oh, what does this mean? Well, what this means is since there's nothing there, that means there's nothing there. Okay, 0 is the number that represents nothing. Okay, but we don't normally leave 0 in when we're looking at an equation because it's kind of, it's not really redundant, it's just meaningless. Okay, I mean 0 does matter, but it so we don't normally leave that. So what we do is we just drop it. We just drop the zeros. And so when you don't have any numbers next to those x's or y's, that means that the center is at the origin, which is 0, 0. Okay, and then here it tells me, again, my radius. I can have a center at the origin and with whatever radius I want, and here the radius is going to be 6. Okay, so this is what it looks like. If I have a circle at the origin, it's going to be right there where the two axes cross. Okay, that's 0, 0. My radius is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then I've got to envision the circle here. See if I hit most of my points. Voila. Okay. So there's my circle with my radius 6 and my center at 0, 0. So x squared plus y squared equals 36. There you go. So I think that's everything for lesson 1, and stay tuned for lesson 2.